Hey guys, how's it going? This is Fixer Med. Welcome to my high yield immunology review series for the USMLE Step 1 NBME CBSE and NBME CAS examinations. This will be part 11 of my multi part video series giving a broad overview of the discipline of immunology. We'll be covering it in a comprehensive but high yield manner. Moving on to the content. Thymus dependent versus thymus independent antigens. Thymus independent antigens, such as certain polysaccharides, do not require processing by antigen presenting cells or binding to major histocompatibility complex molecules. Consequently, they do not activate T cells directly. Thymus dependent antigens, typically proteinaceous in nature, undergo processing by antigen presenting cells and are presented on major histocompatibility complex molecules to T cells, leading to a robust T cell response. Moving on, let's go ahead and talk more about the proteinaceous nature of antigens. Antigens must be proteinaceous to be processed and presented on MHC molecules to T cells. For non-proteinaceous antigens like polysaccharides, conjugation to a carrier protein is necessary to facilitate their presentation on MHC molecules and subsequent activation of T cells. This requirement underscores the importance of protein carriers in vaccines, especially in cases where polysaccharide antigens are utilized, such as in conjugate vaccines against pathogens like Haemophilus influenza type B and Streptococcus pneumoniae. Moving on, let's go ahead and take a look at some NBME style questions now. We have a 28-year-old female who presents with recurrent upper respiratory tract infections. Laboratory analysis reveals low levels of immunoglobulin M antibodies. Which of the following characteristics best describes the antigens most likely responsible for her condition? All right, I think I gave you guys enough time here. If you need more time, please feel free to pause the video. Otherwise, moving on now. The antigens responsible for recurrent upper respiratory tract infections with low IgM levels are likely thymus independent antigens, primarily composed of polysaccharides. These antigens, such as those found in certain bacteria like Streptococcus pneumoniae and Haemophilus influenza type B, do not require processing by antigen presenting cells or binding to MHC molecules. Instead, they directly activate B cells, leading to antibody production, particularly IgM, which plays a crucial role in the defense against encapsulated bacteria. Therefore, the correct answer is C. They are primarily composed of polysaccharides and do not require processing by antigen presenting cells. Let's go ahead and see why the other answer choices are incorrect. Thymus-dependent antigens, not thymus-independent antigens, are proteinaceous in nature and require processing by antigen-presenting cells for presentation on MHC molecules to T cells. This choice does not correlate with the characteristics of the antigens responsible for the patient's condition. B. This choice describes thymus-independent antigens accurately, but it does not specify the composition of the antigens responsible for the patient's recurrent infections. While they do bypass MHC molecules and do not activate T cells directly, the question is asking for the specific characteristic of the antigens associated with the patient's condition. D. While conjugation to a carrier protein is necessary for the presentation of some antigens on MHC molecules to T cells, this option does not address the composition or the direct activation of B cells by polysaccharide antigens, which is more relevant to the patient's presentation. Therefore, this choice is not the best descriptor of the antigens responsible for the patient's condition. Moving on to the next question. We have a 35-year-old male who is receiving vaccinations prior to traveling to a region where Haemophilus influenza type B and Streptococcus pneumoniae infections are prevalent. Which of the following statements best explains why conjugate vaccines are utilized against these pathogens? All right, I think I gave you guys enough time here. If you need more time, please feel free to pause the video. Otherwise, moving on now. Conjugate vaccines are specifically designed to enhance the immunogenicity of the polysaccharide antigens, such as those found in Haemophilus influenza type B and Streptococcus pneumoniae, which are not inherently proteinaceous. By conjugating these polysaccharide antigens to carrier proteins such as tetanus toxoid or diphtheria toxoid, the vaccines enable the presentation of polysaccharides on MHC molecules to T cells, leading to a robust immune response. This mechanism ensures that T cell help is provided for the production of high affinity antibodies and the development of immunological memory against these pathogens. Therefore, the correct answer is B. Conjugate vaccines facilitate the presentation of polysaccharide antigens on major histocompatibility complex molecules to T cells by conjugating them to carrier proteins. Let's go ahead and see why the other answer choices are incorrect. While proteinaceous antigens do activate T cells directly, conjugate vaccines against Haemophilus influenza type B and Streptococcus pneumoniae primarily aim to enhance the presentation of polysaccharide antigens, not proteinaceous ones. Therefore, this choice does not accurately explain the rationale behind the utilization of conjugate vaccines for these pathogens. Conjugate vaccines do not contain live organisms. Instead, they consist of specific antigens conjugated to carrier proteins. This choice describes the characteristics of live attenuated vaccines, which are different from conjugate vaccines. Thus, it does not provide an appropriate explanation for the use of conjugate vaccines against Haemophilus influenza type B and Streptococcus pneumoniae. While conjugate vaccines may indirectly enhance the phagocytic activity of macrophages through the production of antibodies, this mechanism is not the primary rationale for their use. Conjugate vaccines primarily aim to enhance the presentation of polysaccharide antigens to T cells, leading to a more effective immune response against encapsulated bacteria. Therefore, this choice does not adequately explain the rationale behind the utilization of conjugate vaccines for Haemophilus influenza type B and Streptococcus pneumoniae. That's all I have for the content today, guys. If you have any questions, comments, or concerns, please feel free to leave them in the comment section below. If you like these type of videos, please be sure to leave a like and subscribe for more content like this. This is Fixer Med signing off. Be sure to have a great day, everyone, and good luck studying. Goodbye.